Hello student. Now we'll see the new point, that is derivative of logarithmic function. Derivative of logarithmic function, when we use this derivative of logarithmic function, it doesn't mean we have to differentiate all logarithmic functions only. Here we will have differentiable function in that form we could not find its derivative directly. So at that time we'll convert the given function into logarithmic form, then we'll differentiate it, right? So when we use, or what type of functions we will get? In this point we will get function in the form of f of x to the power g of x. It means power of the function is also a power, or power of variable is also a variable. That type of function when we get, at that time we use this logarithmic functions or logarithmic method to differentiate this function, right? Let's see one example, then you will clear it. Suppose function is y equal to x to the power tan inverse x. Here x is also a function, tan inverse x is also a function, right? So this is in the form of f of x to the power g of x, correct? Now if you remember the rule of logarithm, this rule, log a to the power b is nothing but b log a. This rule will use, right? But here in this function there is no log. So what we'll do, we'll apply log on both sides. Not on right side only, we'll apply log on both sides. So log of y become log y. Then right side when you apply log, you will get log x to the power tan inverse x, right? Now if you apply this log a to the power b rule, this b we write before the log, right? So our b is nothing but tan inverse x. So this tan inverse x we can write before log, so it becomes tan inverse x, and here we left log x, right? And left side is log y as it is. So your function look like log y equal to tan inverse x into log x, right? Now you can see this is linear form. There is no power function here, right? So now we have to differentiate both sides, right? But if you see on the right side, there are two different functions, tan inverse x into log x. But both functions are in product form, right? So here for right side, we'll use product rule of derivative. This rule we have already seen in our previous videos, right? So tan inverse x into log x. Tan inverse x we call it is u function, and log x we call it is v function. We also call it is uv rule of derivative. So we have to take differentiation on both sides. So derivative of log y, we have to differentiate both sides with respect to x. So d by dx of log y. Now come to the right side. What was the product rule of derivative? First function constant, derivative of second function, plus second function constant, derivative of first function. So first function constant, derivative of second function. Now second function constant, derivative of first function, right? So derivative of log x is 1 by x, and this tan inverse as it is here. So tan inverse x by x. Now log x is constant, derivative of tan inverse x is 1 upon 1 plus x square, right? But what was the left side? We have to differentiate log y on left side, but with respect to x. So derivative of log y is 1 by y. This was the derivative of log y only. But we have to take separate derivative of this y term, but derivative of y with respect to x, which is dy by dx, correct? So 1 by y into dy by dx. This is the derivative of log y on the left side. Every time derivative of log y with respect to x is always 1 by y into dy by dx, correct? Here we are looking for dy by dx only, but we got 1 by y into dy by dx. So what we'll do, this denominators y we will shift on the right side. On left side it was dividing, but when we shift that on the right side, it will get multiply. It will multiply to all the terms on the right side. So right side term will write this in bracket, and y will multiply it. But don't forget to substitute the value of y. Your y was nothing but your function x to the power tan inverse x. So we'll replace this y here and the remaining term into bracket as it is. So this is your final dy by dx or derivative of this function using logarithmic differentiation. Okay. Now let's see the second example. Y equal to log x to the power sin x. Here log x is logarithmic function, sin x is trigonometric function. So now we'll take log on both sides. Okay. So left side's log y, right side log into bracket log x to the power sin x. Here we applied log on both sides. Now we'll use this formula again, log a to the power b, that is b log a. So here b is nothing but sin x. So this sign will write before our log. So it becomes sin x into log of log x. Okay. Now differentiate both sides because there is no power function here, right? Derivative of log y on the left side. But if you see on the right side, again there are two different functions, sin x and log of log x. Sin x and log of log x means two functions are there. So again we'll use product rule of derivative, right? What was that derivative? Keep first function constant, derivative of second function, right? Plus second function constant, derivative of first function, right? Now differentiate left side also. Log y. In previous example we have already seen derivative of log y was 1 by y into dy by dx. So here also derivative of log y is 1 by y into dy by dx. Correct? Now come to the right side. Here sin x first function constant, derivative of log x. Right? So first we'll take derivative of this log. Right? Derivative of this log is become 1 upon log x. We'll call this total log x as a x term. So your function become log x. And we know derivative of log x is just 1 by x. But here our x was log x. So it is 1 by log x. Done. Now take derivative of this inside brackets log x. So derivative of log x is only 1 by x. Correct? Now plus this log of log x constant and derivative of sin x is cos x. Correct? Now what we'll do? 1 by y, this denominators y will shift to the right. It will get multiplied. This sin x into 1 is just sin x. This x and log x becomes x log x. Correct? And this cos will write before log. It will not change their value. So cos x as it is, log of log x after cos x. Right? And again in final step we'll replace this value of y, that is log x to the power sin x here, and the whole bracket as it is here. So this is your derivative, that is dy by dx of this function log x to the power sin x. Okay. Okay student, now we'll see the next sum. Y equal to x plus 1 to the power 3 by 2 into 2x plus 3 to the power 5 by 2 into 7 minus 3x to the power 7 by 2. In this example also we have to use logarithmic differentiation. But you will say here the power are constant number and the base is variable. So can we use logarithmic differentiation here? Yes, we can use logarithmic differentiation here. So how to use? Let's see. If you take log on both sides, but don't forget there are three different terms on the right side, but all that three terms are in multiplication form or they are in product form. So when we apply log on the right side, how it will affect? So log to this y, that is log y, and log to all these three terms on the right side, right? If you see right side, your right side is in the form of log a into b into c. Log a into b into c is nothing but log a plus log b plus log c, right? So log a plus log b plus log c, log a plus log b plus log c, right? So the first term log x plus 1 to the power 3 by 2. Now here we'll use log a to the power b formula that we have already used in last two examples, right? Log a, we'll write that formula here again. Log a to the power b is nothing but b log a. Right, that formula we are using for all these three terms, right? So according to that formula, this 3 by 2 will write before log like this, 5 by 2 become before pi by 2, right? Similarly 7 by 2 also will write before log, and addition sign are always between them, right? Now we have removed all the powers. Now we can differentiate this, right? So taking derivative on both sides, don't forget we are taking derivative on left side also. So your left side was log y. We have already seen in last two some differentiation of log y. That is 1 by y into dy by dx. Correct? Now this 3 by 2 is constant, so we will not differentiate it. Differentiate only log x plus 1. Right? We know derivative of log x is 1 by x. So derivative of log x plus 1 become 1 upon x plus 1. Correct? Now 5 by 2 is constant, so take derivative of log 2x plus 3 only. So derivative of log becomes 1 by 2x plus 3, but we have to differentiate this term separately. So derivative of 2x is just 2, right? And derivative of 3 is 0. Now last is 7 by 2 constant, derivative of log 7 minus 3x 1 by 7 minus 3x, but we have to differentiate this term separate. Derivative of 7 is 0 minus derivative of 3x is just minus 3. Correct? Now see this. This 3 into 1 is 3 and 2 into x plus 1 as it is here. These two, numerator and denominator, will get cancelled. So 5 into 1, that is 5 divided by 2x plus 3 as it is. Right? This minus and plus become minus. 7 into 3 becomes 21. And this 2 will multiply to 7 minus 3x as it is. So this is your total term into bracket. And we know we want only dy by dx. So left side is this y will shift to the right. It will get multiplied to this total term. Right? And in the last step, we'll replace our y with their original function as it is. And the remaining term into bracket will be as it is. This is the answer, or this is the dy by dx or derivative of this function using logarithmic differentiation. Okay.